What if nearly 70% of the universe's energy density were filled with an unidentified something that no one has ever seen or touched? What if that something were accelerating the universe at this very moment, driving everything apart? In 1998, astrophysicists were using supernovae as clues to precisely measure whether the universe's expansion was accelerating or decelerating. But the data revealed something no one had anticipated. The universe was expanding and accelerating. This discovery shattered the foundations of physics as we knew it. And here's where a crucial question emerges. What if we know absolutely nothing about the nature of this force that accounts for the majority of the universe's energy density? The ordinary matter and light we understand make up a mere 5% of the universe's energy density. Dark matter accounts for roughly 27%, and dark energy for roughly 68%. The identity of the remaining 95% remains a profound mystery. Today, let's venture into the heart of the universe's greatest mystery, the nature of dark energy. By the time this video ends, the invisible force dwelling in empty space will have rewritten your entire understanding of the cosmos. Chapter 1: An Accelerating Universe and the Rules That Broke. Let's begin with a fundamental question. How do we know the universe is expanding at all? It may defy intuition, but the universe is expanding in every direction, like a balloon being inflated. In 1927, Lemaitre established the theoretical basis for cosmic expansion, and in 1929, Hubble and others observationally confirmed that more distant galaxies recede faster. That is the evidence for an expanding universe. Yet at the time, no one could predict what would come next. For decades, physicists believed the expansion must be slowing down. After all, matter attracts matter through gravity. Just as an inflated balloon eventually deflates, the universe was expected to one day reverse into contraction. What shattered that assumption was the supernova observations of 1998. Two independent teams, one led by Perlmutter, another by Schmidt and Rees. Both groups used Type Ia supernovae as standardizable candles, estimating distances from apparent brightness to map the universe's expansion history. Both teams arrived at the same conclusion. The universe wasn't slowing down, it was accelerating. Consider this for a moment. Gravity is a force of attraction. So why is the universe accelerating? In general relativity, a component with negative pressure can drive the acceleration of expansion. That unknown entity was named dark energy. This discovery earned Perlmutter, Schmidt, and Rees the Nobel Prize in Physics in 2011. That speaks to just how fundamental this finding was. In other words, everything we believed about a gravity-governed universe only applied to 5% of it. The remaining 95% operates by entirely different rules. But the real mystery begins here. What is dark energy? Let's look at the leading hypothesis physicists have arrived at. Chapter 2: The universe's greatest mystery lives in the vacuum. When discussing dark energy, one figure is impossible to avoid: Albert Einstein. In 1917, to align with the prevailing view that the universe was static, he introduced a term called lambda, the cosmological constant, into general relativity to obtain a static solution. Later, when cosmic expansion was discovered, he reportedly retracted this constant. Yet after the 1998 discovery, that cosmological constant made a comeback. Ironically, the very lambda he had abandoned became the leading candidate for dark energy. What the cosmological constant implies is vacuum energy. According to quantum mechanics, a perfect vacuum does not exist. Even in what appears to be empty space, particles and antiparticles flicker in and out of existence, and tiny energies fluctuate. This is called vacuum energy, or zero-point energy. The leading hypothesis is that this energy acts as a force, pushing space outward. But here's where the greatest contradiction in the history of physics emerges. When you naively estimate the zero-point energy of quantum fields, it diverges from the observed value of dark energy by as much as 10 to the power of 120. This is known as the cosmological constant problem, one of the greatest unsolved problems in modern physics. This is not a rounding error. This is a contradiction of the highest order, one that shakes the very foundations of modern physics. Let's think about what this means. The two pillars of modern physics, general relativity and quantum mechanics, are saying completely different things about dark energy. Is one of them wrong? Or does a deeper theory exist that we haven't discovered yet? Dark energy may be the key to unifying the two great theories of physics, and we still know nothing about what that key actually is. So what fate does this invisible force have in store for the universe? Let's widen our lens and look at where the cosmos is heading. Chapter 3: The Road to the End of the Universe. Will dark energy remain constant going forward, or will it change? The answer to this question entirely determines the universe's final form. And in 2024, a large-scale galaxy survey project called DESI released startling data. Signs had emerged that dark energy may not be constant, that it could be changing over time. If confirmed, this would force a revision of Einstein's cosmological constant model. Even now, instruments like the Euclid Space Telescope are mapping the cosmos, pressing deeper into this mystery. Scientists are contemplating several end-of-universe scenarios. If dark energy remains constant, the universe will keep expanding as stars slowly burn out, eventually yielding a cold, dark cosmos with no light. This is called the Big Freeze. But if dark energy keeps increasing, a far more dramatic ending awaits. First, galaxy clusters would be torn apart, then galaxies, then stars, then planets, finally, even atoms themselves. This is the Big Rip. However, the Big Rip is a hypothetical scenario that only occurs if dark energy satisfies certain specific conditions. Its timing would vary enormously depending on those conditions. It is not a definitive prediction. Current observations suggest dark energy behaves close to a cosmological constant, but its precise nature remains unknown. I want to pause here and consider. We are still in the middle of measuring the nature of this force that will determine the fate of the universe. Supernova luminosity, galaxy distribution, cosmic microwave background radiation. Only by combining multiple observations do we find evidence that a component driving accelerated expansion is necessary. We haven't reached out and touched it directly, yet there is no reason to doubt its existence. This teaches us that in science, knowing and understanding are entirely different things. Dark energy, which accounts for nearly 70% of the universe's energy density, can be inferred from observation, but its true nature remains a mystery. That means our physics has only captured a fragment of what the universe truly is. An invisible force governs the cosmos. And understanding that force may be the key to the next revolution in physics. When I stand before this mystery, I feel a profound humility. The universe is far richer and far stranger than we imagine. Now, let's gather what today's exploration has revealed. Chapter 4: The Endless Quest. Today, we've ventured deep into the greatest mystery of the cosmos, dark energy. From the shocking discovery of 1998, to the resurrection of the cosmological constant, to the contradiction of vacuum energy, to the end-of-universe scenarios, we've traced the outline of an invisible force. And in 2024, DESI's latest data is shaking that outline once more. The mystery only deepens. Let me share 3 profound insights drawn from today's exploration. First, 95% of the universe is unknown. Ordinary matter and light account for just 5% of the universe's energy density. Dark matter makes up roughly 27%, dark energy roughly 68%. We have learned how dark matter behaves gravitationally, but its particle nature remains undetected. And dark energy, its origin and physical mechanism are entirely unexplained. Second, the vacuum is not empty. As quantum mechanics has revealed, even apparently empty space holds energy. Yet theoretical estimates of that energy diverge from observation by as much as 10 to the power of 120, making this one of the greatest unsolved problems in modern physics, the cosmological constant problem. Third, mystery is the doorway to answers. The mystery of dark energy may hold the key to a new physics that unifies general relativity and quantum mechanics. As DESI's 2024 observations suggest, the universe continues to pose new questions to us. What these 3 insights reveal is the humility of science. What we can observe and what we understand are not the same thing, and the universe stretches far beyond our theories. The more I investigate dark energy, the more I realize how small a corner of the universe I actually inhabit. We float within a force that accounts for nearly 70% of the universe's energy density without knowing what it is. That is not fear. That is awe. When standing before this mystery, everyone stands on equal ground. Nobel laureates and those hearing about dark energy for the first time today alike. The universe distributes its mysteries equally. Let me ask you something. If nearly 70% of the universe's energy density is filled with something unknown, how small a fragment of the whole cosmos is what we call reality? And if DESI's 2024 results hold, and dark energy is truly changing over time, what kind of physics lies beyond Einstein's equations? These questions have no answers yet. But it is the act of asking that has driven science forward. And it is the act of asking that makes us human. After this video ends and you return to everyday life, I'd ask you to stay with one thought. When you look up at the night sky, the stars you see represent just 5% of what's out there. Behind them, an invisible 70% stretches on. In the space that appears to hold nothing, the energy moving the universe resides. That fact alone might make the seemingly empty moments of everyday life look a little different. Standing before the mysteries of the cosmos, the troubles of daily life seem to scale up, and yet, the joy of exploration comes into sharper focus at the same time. Because there are things we don't understand, we keep thinking. Share your insights in the comments. Your questions are the force that drives this channel forward. I'm grateful you stayed with this intellectual journey all the way to the end. The mysteries of the universe, the nature of consciousness, the meaning of existence. On Mindshift, we continue to explore these questions through both science and philosophy. Themes like dark energy, where the answers aren't in yet, are where the journey of inquiry runs deepest. If you're enjoying this channel, subscribe and turn on notifications to join the next exploration. Your curiosity is the force that keeps our journey going. Until next time.